Another idea that comes up early and often in statistics is this idea that correlation does not imply causation. So correlation just means that two things tend to happen together. And causation, of course, means that one of them is causing the other one. And just because two things tend to occur together does not necessarily mean that one of them is causing the other one, even though it's really easy to make that assumption. Let's take a look at a few examples. So it's true that as ice cream sales increase, the rate of drowning deaths increases sharply. This happens every year, like clockwork. So therefore, it must be true that ice cream consumption causes drowning. So there's the correlation in the first line and the causation, perhaps, in the second line. But it may not be the case that eating ice cream causes you to be more likely to drown. It may be that in the summertime, temperatures go up, which means more people eat ice cream, and also more people are in the water, so there's more opportunity for drowning. It's true that young children who sleep with the light on are much more likely to develop myopia later in life, bad eyesight. Therefore, sleeping with the light on causes myopia, and that used to be the understanding or the assumption. And they told kids to turn the light off when you slept, otherwise your eyesight would go bad. But we no longer think that's the case. It's much more likely that kids that have bad eyesight get it genetically from their parents who have bad eyesight. And it turned out it was really the parents who were leaving the light on. Since the 1950s, it's true that both atmospheric carbon dioxide and obesity have really gone up. So, of course, it must be that atmospheric carbon dioxide causes obesity. Or maybe not. I think Christine will have a few ideas about what causes obesity that we'll learn throughout the quarter. But it may be that as nations get richer, they both produce more carbon dioxide and have more readily available food. It's sometimes even true that correlations happen just by coincidence. This is the per capita cheese consumption for the United States and the number of people who died by becoming tangled in their bed sheets. And yes, we do keep track of that. It's one of the possible causes of death that can be listed on a death certificate. And the correlation here is actually really good. It's like a 95% correlation, and we'll learn how to calculate that later in the course. But 95% is a good correlation. So maybe you should eat less cheese if you're worried about dying by becoming tangled in your bed sheets. Or maybe it's just coincidence. And the guy that makes this website, you can see it down here in the corner, Tyler Vegan, he just correlates about 10,000 different factors and variables from various public databases. And eventually, just by chance, some of them, most of them do not match up. But every once in a while, when you're looking at 10,000 different things, some of them are going to match up. Just another small fun example of something that probably is just happening by chance. There's something called the Redskins rule. And it's true that every year, from 1936 all the way through 2000, the outcome of the last home game of the Redskins before the presidential election has predicted who was going to win that election. So from 1936, predicted FDR would win, all the way up through 2000, predicted that Bill Clinton would win. Every single presidential election between those. In 2004, the streak went bust, and it hasn't worked since then.